Okay, good morning everyone. Lesson 8.2, characteristics of quadratic functions. So, we've seen this term before, zeros of a function. The zeros are the x-intercepts. Or in other words, when you factor, last chapter, when you did factoring, right? And then you would solve the equation for the two x values that make it equal to 0, those are called the zeros. They're also called x-intercepts. Okay, they're also just called the solutions. So a zero of a function, right here, a zero of a function is an x value that makes the function equal to 0. Very simple. And they are called zeros, obviously. They are called x-intercepts. They are called solutions. Or they are called answers. Okay? Now, with quadratics, there's three scenarios. You could have, usually we get two solutions or zeros. Sometimes you only get one, and sometimes you even get 0. You could have 2, 1, or 0 zeros. So in these two examples right here, where do the parabolas cross the x-axis? Well, they cross the x-axis right here and right here. So the zeros would be, that's -1 on the left, and then that's +3 on the right. These are the zeros. These are basically your answers. That's all. Notice we have two of them, right? In this one, the parabola only hits the x-axis in one spot at x equals -4. So there's only one answer for this one. Okay, there's only one 0. And then sometimes, suppose we had a parabola that was drawn up here, like that. It doesn't hit the x-axis at all. This one would have no zeros, because it's never crossing the x-axis. Again, the zeros are where it crosses the x-axis. This looks like a new term, axis of symmetry. Very simple. So do you see how a parabola is symmetrical? Like, see how this parabola right here is symmetric? There's a line that goes through the center of it that splits it in half. That is the axis of symmetry, right here. Usually we draw it dotted or dashed. So the vertical line that divides the parabola into two symmetrical halves is called the axis of symmetry. The AOS, axis of symmetry, always passes through the blank of the parabola. It always passes through the vertex. The vertex is like the middle point of the parabola, right? Notice the dotted line goes through the vertex. Always passes through the vertex. So whatever the coordinates of the vertex is also the coordinates of the axis of symmetry. Okay? So this is how you write your axis of symmetry. You write x equals whatever the number is. Very simple. So find the vertex and then find the axis of symmetry. Okay, the vertex is coordinates. Right there. The coordinates are -1, 0. Okay? The AOS, the axis of symmetry, is this line that goes through the vertex. The way you write the axis of symmetry is x equals -1. All right? Whatever that x value is for the axis of symmetry, it also happens to be the 0. But whatever the x value is of the axis of symmetry, that is how you write it. This one, the vertex is up here, right? Let's do the vertex for this one. The vertex looks like 2.5 and 2.5, 4.5. Looks like it's about halfway, right? So it looks like it's kind of in the middle of those boxes there, right? So the AOS, the axis of symmetry, is whatever that x value is. So the x value of the vertex is 2.5. So that's the AOS. And then let's also write the zeros. The zeros of this function are these 2 points right here, x equals 1 and x equals 4. So that's everything you need to list out about a quadratic function when you look at a graph. The vertex, the axis of symmetry, and the zeros. All right, we'll do the next example in the next